Our next panelist is Dan Janzen. Dan Janzen is a graduate of Oregon State with a master's in agricultural development. Dan has over 45 years of agricultural production experience, and 10 years of that have been in international work. Since 2013, Dan has worked full-time in international agricultural development in South Sudan, his home base since 2016, Colombia, Kenya, Uganda, Ethiopia, Tanzania, and Malawi. He specializes in working in the most challenging environments. Janzen teaches best management practices as well as instructing how appropriate technology combined with character development will alleviate extreme poverty, which is particularly important in zones prone to drought, floods, and conflict. Mr. Janzen has presented on the subject of climate change and agriculture at various conferences in Africa and the U.S., and he is a member of the CO2 Coalition. Next, Dan Janzen.
Thank you. Yes, and right now I'm executive director of Fellowship Christian Farmers, and I want to talk about a factual analysis of the point that net effect of increases in CO2 in our atmosphere actually is a positive thing for agriculture. And so if we want to look at the leaf area index across the globe, most people don't talk about this. You don't see much of this. But let's look at the whole globe here, and let's look at how much the leaf area index is increasing. So this green here, and particularly the dark green, is actually a very significant increase in the leaf area index of the whole globe. So much so, in the last 35 years, you can put, from the increase, you can put a layer of leaves across the whole United States, 2 layers thick. You can go over the whole Amazon rainforest with an extra layer of leaves. That's how much the globe has improved, and nobody's talking about this. This is really sad that we're seeing this kind of increase, and this 70% of this is coming from CO2 increases. This is sad that nobody's talking about this and putting a huge amount of money into the wrong things. Let's go look and see what's on the ground here. We've got South Africa savanna. It's a dry area, but yet it's increasing in tree cover. Now, when the alarmists and the catastrophists look at this, they go, oh, that's really terrible. We're getting more trees. Can you imagine? They always want to find a negative reason to debunk things. And look at this, the whole hillside there, hardly any trees. You look, 2010, tons of trees. And 1945, 2018. This is in the Nature magazine. Now, it's not a real conservative magazine. You don't imagine Rephoto, South Africa. This information is out there. You guys can read it. So we can look at various, and then we can look at the fact that CO2 is actually a fertilizer. I'm an agriculturalist, and I can see this as a benefit to agriculture up to about 1,200 parts per million, or even maybe beyond. We don't really know the full extent of this. So every doubling of CO2 is a 33% increase in yield. So look at this. Here's a greenhouse experiment. And you see there, that's how much a pine tree grows there to the left side here. That's how much it grows when it's 385 parts per million. But when we get another 450 parts per million at 835, we're going to get almost like a double of growth. That's very significant. And why is this? Because we have our stomata, and it's the gas exchange place where the transpiration is happening in the plant, and photosynthesis photorespiration is happening there, and they're giving off a whole lot of water molecules, 200 to 400 molecules of water to every CO2 they're taking in. So when you increase the atmosphere of additional CO2, these guard cells or the stomata, they don't have to open as much. They don't have to open as long. And sometimes the plant will adapt and actually produce less of them, because if you go to the herbariums and you look at 1800s, there's a whole lot less stomata there because the plant is adapting. And this is a tremendous benefit to the plant. And that's why your arid zones and stuff are increasing, because it's water use efficiency. It's a great benefit to agriculture. So crops deplete CO2, particularly when the air is not moving in the middle of the day, and you've got maybe 75% depletion in the middle of the day, in the middle of a crop, and you've got about 25% of normal CO2 levels is possible. And so that's really drastic. If we don't have more CO2 level out there, then we're not getting the full capacity of an agricultural crop. So higher CO2 also can be very beneficial to crops because it takes the optimal level of temperature and boosts it maybe another 5 degrees. That's Fahrenheit. I should have all these Celsius. But anyways, apologize for that. So you're looking at a lot of benefits to agriculture from increased CO2. So now, let's add another component to it. Let's look at the mycorrhizae. How many of you guys know about mycorrhizae? Okay, mycorrhizae. And when you combine higher levels of CO2, the mycorrhizae are benefiting from the higher levels of CO2 because the crop or the plant is actually producing more exudates from higher levels of photosynthesis, and it's able to extend itself out further. It's bringing back to the crop all kinds of things, particularly like phosphorus. We're really limited in phosphorus, and most of these mycorrhizals are really good at bringing in phosphorus. And they'll bring in water, they'll bring in all kinds of other nutrients, and sometimes even extending out to a mile away. And it's like having a huge extended root zone. So this is something that maybe we might have a benefit even above 1,200 parts per million. So now, if we're to terraform a planet and we want a greenhouse effect, which is what we have here, and we want higher temperatures in the colder latitudes, temperate, polar. We want higher temperatures at night. We want higher temperatures in the wintertime. What do you get with higher CO2? Exactly that. Why is people complaining? I have no idea. I'm an agriculturalist. Warmer temperatures mean more evaporation and more rain. Okay, yeah, rain sometimes too much of it's a bad thing, but we can manage. We can master the climate. So, but globally, more rain is a good thing. So warmer air holds more moisture. That's a good thing. Air movement across warmer bodies of water, the ocean, lakes, whatever, rivers, the land, it's picking up more moisture and with less energy. Okay, so global carbon uptake has doubled in the past half century. You saw that with the leaf area index increasing. That's where it's going. And sometimes it goes into the mycorrhizae too. It's going different places. So geologically, the CO2 levels are in a slump. And so if we go back in time, you can Google this, you can see CO2 levels at 3,000 or even more. And that's when all these big fossils, you see the fossil trees and stuff, they all grew huge. There's probably a reason there. CO2 level increases historically lag behind temperature. So the temperature increase leads and the CO2 follows. There's reasons for that. You can Google that. CO2 temperature increase fingerprints not in the troposphere. So if you look at these curves that temperature increase and the predictions that are out there, usually those predictions are way off. And so we don't see that fingerprint of what the predictions and the sensitivity to the climate of CO2, it's just not there. Okay, so CO2 increase on temperature is logarithmic. It's diminishing. How many of you guys have ever heard this before? Okay, very few. And you can talk to people and that are all alarmists and catastrophists, and they don't know about this. You ask them, what function is it? And so if you look there at we got 1,000 parts per million CO2. This is what the different predictions are. They're all over the board. But we're gonna show that even this at 1.8 degrees Celsius is not a huge terrible thing for our planet to go up that much temperature, because we're going to look at the medieval warm period in a moment. And also we're going to look here now at this at the fact that 77% of our current CO2 level is absolutely necessary for life on planet, okay? And we go over here and we can see that 13% of the influence of the climate, of the sensitivity to CO2 is what's remaining. Let's show you on the next slide what this actually looks like. So now we see over here 20, 40, 60 parts per million of CO2. That's a huge greenhouse effect right there. But now we don't see much greenhouse effect from the additional increments in increase in CO2. It's just not there. So we're not going to see it. No matter how much the CO2 level goes up, we've got about 13% influence left. That's what we see scientifically. Okay, now you can see though that the curve is very different. It's not so much of a diminishing curve. We're getting, when we add 300 parts per million to crops, we're going to get this 50% or maybe somewhat less increase in crop production. That's great for agriculture. Okay, so let's look at the Little Ice Age. The Little Ice Age shows us what it's like to have a really bad climate. Okay, less sunspots, increased volcanic activity, production rates fell by half, widespread famine and cannibalism, particularly whenever there was a volcanic eruption, 2 or 3 years, tens of millions of people dying of famine because of low temperatures and summers that don't even exist when a volcano goes off. If we want to bank on having warmer oceans, that's actually a good thing. What's happening now? Cultivatable land shrunk. Witches blamed for climate change. It wasn't just a few years before we had the medieval warm period. The witches, and people blamed the witches because the temperature was changing. And you can go back and there's papers on this. Famines, and they burned them at the stake because they thought they were causing the frosts and everything. And famines caused by, in China. You can go back and you look at the record. Dry, cold weather in China produces a famine. Okay. Droughts. Medieval warm period. Now this is what it shows we can see at a good climate, okay? During the Chaucer's age, medieval warm population in Europe doubled. Poor harvests and famines infrequent. Grain was grown in Iceland, Greenland. Imagine, grain grown in Greenland, it was grown. And we're just starting to be able to grow grain in Iceland, but not in Greenland. Northern fisheries flourished, vineyards. 500 kilometers further north, we had vineyards in Finland even. And you look at, and this is on the internet, you can look, 200 meters higher elevation than today. Permafrost in Greenland. We dig down, we find exhume a Viking body. There's tree roots in the Viking body, okay? That's documented. It's there. And today it's permafrost. It's vastly, I don't know how many degrees Celsius this is above, 2, 4 degrees Celsius to have this kind of effect. Retreating glaciers leaving tree stumps behind. Okay? That's a much warmer temperature back then, and it was a good temperature. Tree lines located at least 100 to 140 meters higher than today. Proxy temperature measurements, they back this up. Tree ring, you can analyze tree rings, the oxygen isotope, all these the ice cores, they're all backing this up, that the medieval warming period was much warmer. So what are our top ranking issues today for our health? Okay, what are they? Are we off target here? I think we are. I think we need to be looking at indoor air pollution, cooking, heating. 4 million deaths from respiratory infections, almost 4 million from chronic, just from the smoke people are breathing. It's nasty to be inside of a home with a whole bunch of smoke and you're breathing it. That is an 8 million contributor. That's dwarfs any other environmental hazard. And then the next, let's look at contaminated water, lack of sanitation, things we can fix. 1.6 million children dying from that. Malaria, 1 million. These are things we can fix if we put our resources in it. We're wasting all our resources on this climate change thing. Okay, you go to China, tailing ponds, huge tailing ponds with all kinds of acid fumes coming up. Do you want to live in that kind of environment? What's driving it? What's driving it is our demand for solar panels and for wind turbines and for batteries and for other things we use in our electronic components. But there's the big parts of what's driving this. And the Chinese don't mind. they'll acid etch their soils to take rare earth elements out. And the people have cancer rates high and teeth falling out and hair falling out just being downstream or in the vicinity. Now, India, the wheat production is going up. So we don't need to be a doomsdayer on crop production. Other crops are going up. The yield is going up. It's not a bad thing. So we're going to spend $100 trillion in order to reduce the temperature by the end of the century, 0.3 of a degree. And if you got Will Happer here, his information says that it's 3/100 of a degree. We're gonna benefit from all this Paris, Kyoto, COP biased policy. So it's going to postpone the warming very little. So even Al Gore seems to be knowledgeable about the fact that we hit our targets. We're not going to really benefit. He says that's correct. Okay. So our best resources, I've listed them here, and I don't have time to go into all because I don't want to make this too long. But you can check it out, and you can also send me an email. Love to hear from all of you and get some feedback on what I presented here today. And my conclusion is that free market and human ingenuity in the context of advocacy for policies that prioritize human flourishing have potential to alleviate scarcity. We don't need this Malthusian anti-population ideology because everybody in the world is to be valued, and we're to cherish everybody and to pour our lives into developing them into the people that are going to bring abundance and human flourishing to this planet. So let's stop all of this nonsense about non-impact and humans being a blight and a polluters and delicate nurture ideology. It's anti-human flourishing, and it's really, really a bad idea. So thank you.